So when we talk about trig identities, we're basically talking about what another trig formula or trig ratio is it equal to. Can we identify it from a complicated scenario, complicated equation? So basically, it's an identification. If you take out an ID book right now and you show me it, I'm supposed to know from that ID book if this person is you. And from your ID book, if it's your ID book, I can determine your name, the date of your birth, everything about you. By trig identities, when I see sin²θ, what other information can I get from it? If I see 1, what other information can I get from that 1? When I see cos²θ, what other things should I know from cos²θ? If I see tangent, what do I know tangent is equal to? Trig identities is what certain trig ratio is equal to. What other thing is it identical to? That's the whole point of trig identities. How did they come up with trig identities? On the last video, I made it specific that trig ratios are only meant to be used on right angle triangles. You only use the statement SOHCAHTOA on right angle triangles. At the same time, you can also use Theorem of Pythagoras on a right angle triangle. When you get to the 11th grade and the 12th grade, you realize that there's a sine rule now, there's a cosine rule, there's an area rule, but we'll get to those. Now, since we're talking about a right angle triangle, and I did mention that you can use the Theorem of Pythagoras, right? This right here is basically the Theorem of Pythagoras. On the last video, I made it clear that y is the opposite side, x is the adjacent side, and r is the hypotenuse, side. From the Theorem of Pythagoras, mathematicians were able to come up with trig identities. How did they come up with trig identities? By dividing a simple equation of Theorem of Pythagoras. Let's start dividing by r squared. R squared. Now mathematically, we already know this is already 1. Right? Now, I want us to agree. X over r is adjacent over hypotenuse. And adjacent over hypotenuse is what? Is cos. So that will be cos²θ. Let's just use the angle of theta. You can use the angle of beta. You can use the angle of alpha. You can use the angle of theta. It's your choice. The choice is yours. You can also use the angle of omega. Plus y over r is opposite over hypotenuse, which is sin²θ. The reason they're squared is because x over r all squared is still the same as x squared over r squared. From just dividing by r squared, we were able to identify our first trig identity. Cos²θ plus sin²θ is equal to 1. Keep in mind, these angles have to be exactly the same. If right here is supposed to be beta, then that means here it's supposed to be beta too. This right here, cos²β plus sin²θ, is not equal to 1. Those angles have to be exactly the same for this to work. For our second identity, we're just going to keep on transposing things. Let's just first transpose cos. 1 minus cos²θ is equal to sin²θ. 1 minus cos²θ is equal to sin²θ, right? Now the third identity, we're going to basically use the first identity to identify these other two identities. So cos²θ is equal to 1 minus sin²θ. Now, this is how we identify. Sometimes you can come up with you can just see something like this. 1 minus sin²θ. And you're like, man, I know this is equal to something. when you get that instinct, when you get that 1 minus sine squared theta is equal to something, you should definitely know that you should identify that it's equal to cos squared theta. So just the same way when you look at somebody's document, you get more information about him. That's the same way when you look at 1 minus sine squared theta, you'd be like, oh man, I'm getting a whole lot of information. What do I know that's identical to 1 minus sine squared theta? Now, with these also, you can also say sine theta is equal to the square root, the plus or a minus square root of 1 minus cos squared theta. Why? We took the square root of both sides, right? You know that square root is plus or minus. The same way, cos theta is also equal to plus or minus square root of 1 minus sine squared theta. But you won't be needing this in the 10th grade. So let me just erase it. In the 10th grade, you guys are only supposed to know these trig identities. We can also get more identities when we divide by x squared, when we divide by y squared. Now let's divide by x squared. The 10th, 11th, and the 12th grade curriculum in South Africa got rid of trig ratios, reciprocals. A reciprocal is the numerator being the denominator and denominator being the numerator. That's a reciprocal. 2 is still the same as 2 over 1, right? But if I want the reciprocal of 2, it'll be 1 over 2. That's the reciprocal of 2. What did I say? They're equal. So the reciprocal of 2 is 1 over 2. The denominator becomes the numerator and the numerator becomes the denominator. The reciprocals of the trig ratios that I mentioned, sine, cos, and tangent, their reciprocals have names too. X over r, this is cos. The reciprocal of cos, which is r over x, is called sec. It's a secant. So we're going to get secant squared theta being equal to 1 plus y over x is opposite over adjacent, which is tangent. Tangent squared theta. You can also do the same thing that we did to the first identity to see how many things are equal to 1 in trigonometry. Sec squared theta minus tangent squared theta is equal to 1. Now let's divide by y squared. A reciprocal of sine is cosecant, is cosec. The reciprocal of cos is secant, or you can say sec. The reciprocal of tangent is cotangent. Since sine is y over r, the reciprocal of sine is cosec squared theta. So I'll just be using theta as an angle. The reciprocal of tangent is cot. We'll just be writing cot squared theta plus 1. I can also identify what other identity is equal to 1. Cosec squared theta minus cot squared theta is equal to 1. That's another identity. Now from this identity, sin squared theta plus cos squared theta is equal to 1, right? We're able to identify that sin squared theta is equal to 1 minus cos squared theta, right? Sometimes they can just give you something like this, -1 plus cos squared theta. You can take out a common factor of -1, and then what will remain in there will be 1 minus cos squared theta. And then what do? 1 minus cos squared theta is equal to sin squared theta. It will be equal to -sin squared theta. So whenever you see -1 plus cos squared theta, just remember that it is equal to -sin squared theta. They can also give it to you like this. They can give it to you as cos squared theta minus 1. So cos²θ minus 1 is still equal to negative sin²θ. From this, we're able to say that cos²θ is equal to 1 minus sin²θ, right? And then again, sin²θ minus 1 is equal to negative cos²θ. Or you can say negative 1 plus sin²θ still equal to negative cos²θ. Always remember this. Now, quotient identity. And so far, I haven't seen another quotient identity. This is the only quotient identity I know. Tangent theta is equal to sine theta over cos theta. This right here is what we call a quotient identity. Quotient is division. So whenever you see sine theta over cos theta, you should automatically know that it's equal to tangent theta. Tangent squared theta is equal to sine squared theta over cos squared theta. Now keep in mind, for us to change sine over cos to tangent, both sine and cos gotta have the same angle. So sine theta over cos theta is equal to tangent theta. Tangent theta is not equal to sine theta over cos beta. Tangent theta is not equal to sine alpha over cos beta. No, it's not. For us to change sine over cos to tangent, both sine and cos must have the same angle. It's not only just theta. It can be alpha over alpha. Sine alpha over cos alpha can give us tangent alpha. We have no problem with that. Tangent alpha is equal to sine alpha over cos alpha. Tangent beta is equal to sine beta over cos beta. What I'm truly saying here is the angles must be exactly the same for this to work. That's the most important thing about quotient identity. You're going to use it a lot in the 11th grade and also in the 12th grade. I'm going to go through all of that with you. I'll see you guys in the next video. Stay tuned.